Today we are going to talk about evaluating and graphing polynomial functions. The first thing to keep in mind is that a polynomial is a monomial or a set of monomials. And a monomial is like 2x plus 1. That is a monomial. Alright, so what we're going to do is we're going to talk about the polynomial function. In function form, it looks like f of x. Alright, f of x is function form, or y equals. And for your calculator or graphing, you do y equals. Function form, you say f of x. Alright, in the standard form of a polynomial function, you go from highest exponent all the way down to no exponent. So I'm going to say 3x cubed plus 2x squared minus x plus 5. Because my highest exponent down to minus 1 gives me the next highest, down to minus 1, which is the next highest, down to nothing at all. So you do descending order from highest exponent to no exponent. Now, if it is not in standard form, which is highest to lowest, you have to put it in that form. So if we have it as 2x squared minus x plus 3x cubed plus 5, we have to understand that my highest exponent is not first, so I need to rewrite it. And so I would move this to the front, 3x cubed, bring everything else down, plus 2x squared minus x plus 5. And now you can see that they are the same. So this is standard form. Now, in standard form, you can find the leading coefficient and the degree of the function. The degree is going to be your highest exponent, and then your leading coefficient is the number attached to your highest exponent. I was trying to do different shapes there. Alright, now, so in this one, the leading coefficient, it's the number that starts the function, is 3, and the degree is 3. Now, the degree is important because it lets you know how many answers you're going to have for this equation, or at least how many possible. There might be a time where they come to be the same answer, but that's how many possible answers you will have. To evaluate or solve polynomial functions, there are two ways to solve. The first way is direct substitution. For example, I have f of x equals 3x squared minus 2x cubed minus 3. Alright, so there is my function, but I see that it is not in standard form. In standard form, I have to have my highest degree, which is the highest exponent, in the very front of my function. So I'm going to rewrite, and it's going to be, this is equal to a negative 2x cubed plus 3x squared minus 3. Now it is in standard form. Now, here's my function. Say it says when when x equals a negative 3. What that means is for every x, I'm going to put a negative 3 in its place. So I'm going to do that now. A negative 2 times a negative 3 cubed plus 3 times a negative 3 squared minus 3. All I did was rewrite. From here, I can go ahead and solve. But one thing to keep in mind is when we have a negative 3 cubed, anytime your exponent is an odd exponent and your number is negative, your answer for this negative 3 cubed will be a negative because it's an odd exponent number. If it's an even, it's always going to be positive. Alright, so I'm going to rewrite negative 2, and I'm going to evaluate a negative 3 cubed, which is a negative 27. I'm going to evaluate a negative 3 squared is a positive 9, and then bring down my 3. At this point I have 54, because a negative times a negative is a positive, plus 27, 3 times 9 is 27, minus 3. So 54 plus 27 minus 3 will give you 78. That is your evaluation in direct substitution form. Now we're going to work synthetic substitution. What is important with having a polynomial function in standard form, it comes into play with synthetic substitution. In synthetic substitution, you have it in standard form, which this is not, so again, I'm going to rewrite it in standard form, having my highest exponent, which is my 3, to be the very front. So I'm going to say f of x equals a negative 2x cubed plus 3x squared minus 3. Now, when we put it in synthetic substitution, you're going to draw an upside down division box. When x equals a negative 3 goes on the outside of your box, and your numbers, only the numbers, not the exponents and not the variables, go inside the box. Make this lower. So let's do that now. I've got a negative 2 because that's my highest exponent. I have a positive 3. That's my next highest, but there's no just plain x. You have to have it from highest to nothing with every single number being accounted for. So because there is no plain x in synthetic substitution, you have to put a 0 in that place. And then my no exponent is a negative 3. Now, this is how you set up synthetic substitution. Now, what I'm going to do is to solve synthetic substitution, the very first number comes straight down, so a negative 2. What you do next is you multiply the outside, a negative 3 times a negative 2 equals a positive 6, and you put it inside. You add positive 3 to a positive 6 gives you 9, and you place it back on the outside. You multiply the outside, a negative 3 times 9 gives you a negative 27, and again you add 0 plus a negative 27, which leaves you a negative 27. Last time we multiply the negative 3 times the negative 27, because they are the two outside numbers, and you put the answer, 81, inside. And we do the addition, a negative 3 plus 81 gives us 78. And again, that is your evaluation using synthetic substitution. Most homework, they will say to use any method. Since we have shown synthetic substitution and direct substitution, that means that you can literally choose either one. What I'm going to do is synthetic. So I'm going to set this up. First thing I want to do is see if this is in standard form. My highest exponent is first, and so it is in standard form, but at the same time I can see that I am missing x squared. And so when I set up my synthetic substitution, remember, anytime you have just an x, that means 1 times x, because anything times 1 is itself. And so I can put 1, and then there's no x squared, so I have to put a 0 in that spot. Then I have my negative 8, and I have my 6. And again, my negative 3 goes on the outside. First step is to bring down the very first number, which is 1. I multiply negative 3 times 1, because you always multiply outside. You add inside. So 0 plus a negative 3 is a negative 3. You multiply outside. A negative 3 times a negative 3 is a positive 9. You add inside. A negative 8 plus 9 is 1. You multiply outside. A negative 3 times 1 is a negative 3, and you add inside. 6 plus a negative 3 gives me 3. And there is my evaluation of g of x equals x cubed minus 8x plus 6 when x equals a negative 3. The last part of this lesson is graphing the polynomial function. So it's going to say graph f of x equals a negative 3 minus 2. The way to find points to put on a graph is you're going to make an XY table. So I'm going to do that over here. I put my X on top, I put my Y on bottom. You choose what numbers, and what I do is I choose numbers as close to 0 as I can. So I'm going to do a negative 2, negative 1, 0, 1, and 2. Now what that tells me is that I'm going to place a negative 2 into my X and solve. So I'm going to say a negative 2 cubed minus 2. So a negative 2 cubed gives me a negative 8, but a negative times a negative is a positive, so this becomes 8 minus 2, which is 6. So now I know my y for x minus equals a negative 2. I want to do the same thing for a negative 1, a negative 1 cubed minus 2. Again, a negative 1 cubed is a negative 1 times a negative gives me a positive 1 minus 2 gives me a negative 1. So I put it back in my table. I'm going to do it a third time. A negative 0 cubed minus 2. 0 to any power is going to always be 0. And you don't have a negative 0 because a negative is just 0. So we have 0 minus 2 equals a negative 2. The next one, we have a negative 1 cubed minus 2. So we have 1 cubed is 1 times our negative. So a negative 1 minus 2 gives us a negative 3. And then our last one is 2 cubed minus 2. So this is 8 times the negative. So a negative 8 minus 2 gives us a negative 10. From here, we can make a graph of this. And I'm going to make my graph. And I'm going to count by 2's. You always want to tell me what to count by, so I am counting by 2's. So that lets me know that every line that is on here is another 2 instead of counting by 1's. All right? So you're going to put these on here. And I'm going to look and remember how to plot points. You go over first, so I'm going to go over my negative 2 because you go left to go negative. And I'm going to go up a positive 6. 2, 4, 6. And I plot my point. I'm going to go over to a negative 1, and this time it's a negative 1. So I'm going to plot my point. This time I have 0, negative 2, I plot my point. 1, negative 3, I plot my point. And then 2, negative 10, and I plot my point. All right, now you connect your dots. And I'm going to start right here because there's my curve. And then I'm going to go like this. And there is my graph of f of x equals a negative x cubed minus 2.